Hi everybody, welcome to Socsci10. This is discussion number 7. We're going over normal distributions this week. These are very important, probably the most important distributions in statistics, and you got to make sure you know this stuff. So in the book they talk about these 7 characteristics of normal distributions. I'm just going to go over them real quick with you, and it's important to understand these. And then we'll talk a little bit about z-scores. So the first thing you got to know is, looking at, this is a normal distribution on the right, this is a picture of a normal distribution, is that there's symmetric around the mean. So you can see mu there is right in the middle. It's the center line going up with the u with the little tail in the front. That's the mean, and the normal distribution is symmetric about that. It's equal on each side. Second thing you need to know, second characteristic is the mean, median, and mode of a normal distribution are all the same. They're all equal. So the mean is also the most common, and the mode is also the middlemost point, so you get a fully symmetric on either side. That's why you have the mode there, is lined up onto the mean, and then the median. So these are all, values are all equal. So if you know one, you know the other if it's a normal distribution. If you know the mean, you know the mode of the normal distribution, and you also know the median, and vice versa. So now, the normal distribution, the area underneath the normal distribution is equal to 1. So when, in this case, when you're talking about something that's normally distributed, you're basically saying, like, you're describing how probable these things are, right? And if you take into account all the possible things, then it's going to add up to be 1. So the area under the normal curve is going to be 1, including the tails, which never quite reach 0, but they get very small as they go out to infinity on either side. And you can do an integral, and the sum of that integral will give you that the area under the entire curve is equal to 1. Now, the distributions are more in the center, and they're less dense in the tails. So looking at the image, the red areas are the tails. There's not a lot of probability mass at those locations. But the probability mass is lumped up around the mean in the middle, right? That's where you're going to get the majority of the mass of the distribution. And you can see here that the green area is that area where most of the mass of the distribution is located. And within one standard deviation, that's 1 sigma to either side, 68.2% of the mass of the total distribution is located within 1 standard deviation. And if you go out to 2 standard deviations, it's 95.4. 3 standard deviations, 3 standard deviations, that's basically the entire distribution, except for a very small part of the tails, and that's at 99.7. These two parameters, the standard deviation and the mean, they really define the entire standard the entire normal distribution. The mean could be shifted some way, and it could be stretched horizontally, right? That would be the standard deviation. And the important thing to remember is, like, 68% of the normal distribution is located within 1 standard deviation of the mean. So the further out you go, 2 standard deviations, things become much rarer to be further out than 2 standard deviations. 3 standard deviations, very, very rare that things will be further away than 3 standard deviations, but it's possible. And about 95% of the area of a normal distribution is within 2 standard deviations of the mean. So you can see here that this standard deviation, it really tells you how rare things get, how uncommon things get as you move further away from the mean in the distribution. So these 7 aspects of a normal distribution are important to understand. It's important to understand how a normal distribution is defined. It's mostly the mean and the standard deviation, and the area under the curve, which is how much of the distribution is being captured within the standard deviation, and that mean, median, and mode. If you know one, you know all of them for standard deviation. All right, so let's talk a little bit about z-scores. So a z-score is really how many standard deviations is from the mean of a normal distribution. So if you go back to the previous slide, you see down here at the bottom the z, right? If z is -3, that's -3 sigma, which is the 3 times standard deviation. So when you have a value and you compute a z value, it's going to give you a z value. It's going to be an integer, but it's really telling you, if you multiply that by the standard deviation, it's going to tell you where you're located on the standard deviation. So that's really what the z values are. And you can compute that using a formula for z, which is equal to the value you're looking at, x, minus the standard deviation, minus the mean, which is mu, divided by the standard deviation. That's how you compute this z value right there at the bottom. You're going to divide it by the standard deviation. You're going to take the difference between the value you're looking at and the median, the mean value, which is mu, and that's going to give you your z value. That's how you compute those z values. Okay, and finally, you're going to encounter something called a z-table. Now, what is a z-table? A z-table tells you how much area is underneath the normal curve to the left of that z value. So in this case, the z-table you see on the left, and let's just wait a minute because we have an airplane going over, a very loud airplane. Okay, so I'm going to repeat that. So the z values on the left are the z-table on the left. It tells you how much area is under the curve to the left of the z value. And the way you read this table is, if you're to the left of the mean, right, on the left side of the distribution, you're going to be negative z's. If you're going to be onto the right side of the mean, you're going to have a positive z values, right, just like you do here on this chart. And on this table is divided into two sections. To the left are the negative values, to the right are the positive values. And you can see by the little graph at the top of each side of this chart, it shows you the z values are to the left or to the right of, it's looking at z values to the left or to the right of the mean, which is the tallest part, at the tallest part of these graphs. And the way you read this is you look at the z values, the column on the far left, but it only goes to one decimal place, and then the rest of the columns are the second decimal place. So you say, if you want to know how much area is under the curve, you look down to find your z value, and then you can go across the columns to get an additional digit of accuracy. The hundreds column of accuracy. So combining those two, you can get to a 4-digit decimal position valuation on the area underneath the curve, z values. And these are often computed, the z-scores are often computed to understand how much is below or above left in this distribution of these z-scores. And suppose you want something on to the right. Suppose you wanted the area to the right of the z-score, right? Rather than to the left. So these tables tell you what's on the left. Well, you just take the complement. So if you know the area from this table to the left of a given z-score, and you want to know the area to the right instead, you just subtract it from 1. Right? 1 minus the area to the left is going to be the area on the right, because remember, the total area underneath the normal curve is a 1. Right? So you can use the complement rule to get the area to the right of a given z-score. Well, that's it for today. I hope this is helpful on the homework this week. Good luck on that, and I'll see you guys next week. Have a good weekend.